Oh, I got a message that said recording in progress. Okay, so welcome to Google App Scripts, APG Professional Development. So tonight, first of all, let's make clear. This is what we're not going to do. I am not going to be able to teach you how to write Google App Scripts. not exactly. So I laid out. I did send to everybody some notes about the presentation tonight, and right at the top I said what my goals are. So here are my goals. I want to provide just kind of a broad overview of the Google development environment, talk about what app scripts can do and why you might want to use them. Hopefully maybe invoke a little bit of curiosity, and we go over some examples, some real life examples that we use in the gallery, hopefully, and provide some resources, which I've done in the back of the notes. The last section of notes is some resources that I actually have open up here anyway. So first of all, the Google environment. I started off saying macros are scripts that you never have to see, and we'll talk about that in just a minute, because if you just open, if you go into the Google development environment and just open the script editor, there's nothing there. It's just literally a blank page, and you say, well, okay, well, what do I do now? So we're going to create a very quick macro and then open that, because Google writes its macros. When you create a macro, Google writes it as Google Apps Script and stores it in the same place that you can write your own. I don't know if anybody has written a macro or not. The way, actually, you don't write a macro at all. You typically record a macro. You go into a Google Sheet, do some activities that you want to do repeatedly, and record it as you go, and then it creates the macro for you. So we'll talk about that in a minute. But in general, the Google development environment is a development language, and all modern development languages, computer development languages, are object-oriented. A long time ago, they used to be just procedurally oriented, and they still are to some extent. A program tells a computer step-by-step instructions, what to do next. But the instructions are very much based these days on objects, and objects, or sometimes called classes, have properties, and they have methods or functions that you invoke, and then the object itself executes the code to invoke that method. All right, so that is called object-oriented programming, and Google Apps Script is based on any program like that is based on an object model, which defines what those classes are and what those objects are and what the methods are and what you can do with them. So Google Apps Script is one of those. Google Apps Script has an object model for every one of its applications. There's an object model for Google Docs, an object model for Google Sheets, one for Calendar, one for Gmail, and so on. To use the Google development environment, what's great about it is you don't have to buy anything. You don't have to install anything. It's all there. It's all free, and you use it all right from your browser. Okay. So that's just kind of an overview. I'm not going to read these notes word for word from now on, but I just wanted to get through that. So let's talk about this idea of a macro, because the first thing we're going to talk about after we explore that macro is the elements of the Google Sheets object model in particular. So let's just let's start out by opening I'm going to go here, and I'm going to in Google Drive, and I'm going to open a new Google Sheets. Okay, and I'm going to record a kind of a quick and dirty macro. First of all, let me show you what the Google development environment is from Google Sheets. You can go into Tools, you can go into Script Editor, and this is what you see. you've got a place to write code. And every code that you write, all the code that you write in Google Scripts is going to be part of a function. A script will contain one or more functions, typically, oftentimes just one, because they're usually pretty short and just do very specific things. But this is where you're at in the Google development environment. You just kind of scratch your head and say, well, what the heck do I do now? Okay, so I'm going to close this for now, go back to the spreadsheet, and I'm going to create a macro. So the way you create a macro, go into that same tools menu and macros, and you can say, record a macro. And it's telling you down here that a macro is now recording. So what we're going to do, let's try to do, I wanted to think of something that you might want to do useful. A macro or a script is useful if you do a process over and over and over again. And maybe it's tedious, or maybe it's just, not that tedious, but you do it so many times, it's worth being able to do it with just a click or two. So let's prepare on my Google Sheet a header row. So I'm going to choose row 1. I'm going to right click and say, let's resize that row because I want it to be bigger than just the standard row. So I'm going to specify the row height and say, let's make it 60 instead of 21, okay? Let's go further while I have that row selected. Let's make everything in that row will be bold, all right? And let's make it so that everything in that row will wrap text, all right? Because these are where my headers are going to be. And let's do one last thing. Let's freeze that row, freeze one row, so that when you scroll up and down, can't tell what's happening, look at the numbers here. When you scroll up and down, the row stays the same. And that's all I can do, that's all I need to do for my macro. So I'm going to save it now. I'll name this header. I could name it. Okay, so my macro is now saved. So right now I did all that stuff by hand, so obviously it works. If I type in here, then it's bolded and everything that I did obviously is there. But let's see if the macro really works. And the way you make that work is, let's add a new sheet in the same spreadsheet, and this time go back into those tools and macro, and let's execute header. And we're going to have to go through this authorization process. Remember, if you've ever used Label Maker or anything like that, it says, even though this is my macro, I have to do this. So I'm going to do this as me. I know you haven't verified this app. Go to Untitled and allow. Now this is a once and done thing, but it's kind of annoying, but it's Google's way of protecting you. So it's a good thing ultimately. So let's try that again. Tools, macro, execute header. And it's changed. And obviously if I type in here, header 1 and this text will wrap, and it does. So that I've set up my header row without 3 or 4 steps with just one macro. The only reason I wanted to do this tonight, though, is not to show you how to make macros as much as go into that script editor, back into that script editor, and notice there's something new here now, macro.js. And this is what I did, okay? If I knew how to, I could have just written this function manually myself, all right? But what this is using is the Google object, or the script, Google Sheets object model, okay? So the object model is essentially follows a spreadsheet, is a definition of a spreadsheet. I'm going to go back to a spreadsheet just for a moment and think about a spreadsheet. A spreadsheet contains sheets, okay, sheet 1 and sheet 2. A sheet contains cells. In the script terminology, a sheet contains a range. A range could just be a single cell. It could be, a range of cells, but, sheets contain ranges, and ranges contain values or formulas, okay? So there's kind of like a hierarchy, and the object model also has a hierarchy. In this case, remember I told you everything they execute in Google Script is a function. So this is called function header because that's what I named the macro. Says it declares a variable. VAR is a way of declaring a variable in JavaScript. The Google scripts make use of two things, the Google object model and a programming language called JavaScript. JavaScript doesn't belong to Google. It's not part of Google. It's a widely used development language, computer language for web development. But Google Scripts uses it. So we declare a variable, var spreadsheet equals, and we've called this object called spreadsheet app, and we've said get active. And that essentially has gotten the active spreadsheet. We've gotten the range, which when I think that's when I selected that whole first row and made that and activated it. We've set the row height for row 1 to 60. We've set the range there as the font weight as bold and the wrap strategy as wrap. And this is kind of a little bit gobbledygook spreadsheet, active sheet, and we froze the row. I can kind of follow what's going along there, but I really wouldn't know how to write that per se. We're not going to do anything more with this code. Whenever I'm going to sit down and actually write code, I always have some things open. I always have some resources open, some documentation. There, I've got these things bookmarked, in my browser. But here is kind of like the Google Apps Script homepage. All right, it's the guides. Okay, and in the guides are I find this particularly useful. Learn Google Apps Scripts, and there's just some examples. Here's managing Google Forms and responses, menus, and custom functions. All right. What's nice about this is I learn by mimicking, by copying, and so there is always some code in here. It's well documented code. All this stuff you see in red are just comments that explain what the code below it is about to do. The comments are usually in English. And then, I can see some examples. All right. I can't necessarily make sense of everything that I'm looking at right now. But there are some examples and I can follow those examples. The other thing is in this same page, there's references, there's a homepage. I almost always have guides and references open side by side because the references, that's the rules. That's where I'm going to really learn the syntax and exactly how to write this thing. Again, let me go back up here. References, in references, when you first open it, it'll look something like this. I don't care a whole lot about manifests. Manifests have a lot to do with deploying these applications on the web. Doesn't really concern us too much. Google Workspace Services is where you'll find mostly what you need. There's Workspace, there's an object model for spreadsheets, slides, Gmail, forms, calendar, so forth. So the spreadsheet object model, the overview is, here's lots of classes. I don't think this is a list of all, maybe it is. No, I don't think that's a list of all the classes. At any rate, like I was talking about with the spreadsheet, that spreadsheets contain sheets and sheets contain ranges. The object model is very similar to that. It's hierarchical. So under the top of the hierarchy is this thing called a spreadsheet app. And a spreadsheet app, if I click on that, then what happens over here is I see all the things that have to do with spreadsheet app. And spreadsheet app is where I can create a new spreadsheet. Okay. Can create and give it a name. All right. And there's a little bit of a sample code snippet. It says var creates a variable, spreadsheet new equals spreadsheet app dot create, and gives it a name finances. And that will create a brand new spreadsheet called finances. It will be in the root of your Google Drive is where it will get created. Okay. I can create a spreadsheet and specify how many rows and columns I want. I can open an existing spreadsheet. I can open by ID is the way I typically would open an existing spreadsheet if I were not already open. In other words, if I weren't already in it. So open by ID, and it tells you if you have a spreadsheet open, you can look at the URL of that spreadsheet, which is right here. And this string, everything from the /D, this string all the way over to the edit, that's the ID of this spreadsheet. So you can grab that ID, go back there, and it explains it right here. You can grab that ID and say open by ID and just paste it in there, and it will open that spreadsheet. Okay. That's about all I do with the spreadsheet app is either create spreadsheets or open, open existing ones. Okay. But then once the spreadsheet is open, then there is a spreadsheet object or a spreadsheet class. And the spreadsheet class is the thing that contains sheets. Some things you can do by shortcut. You don't have to go to sheets, but spreadsheet class, you can get the number of sheets in the spreadsheet. You can get the sheet by, you can get the name of the spreadsheet, spreadsheet.getName. You already opened it. So now you can say spreadsheet app get active spreadsheet, and then get the name of the active spreadsheet if you have a reason to do that. But you can get sheet by name if you know what the name of the sheet is. You can get the sheet ID. There's ought to be just a get sheets. Okay. Get sheets returns an array of all the sheets in the spreadsheet. Maybe there's only one, in which case the array just contains one element. But so this is var sheets equals spreadsheet app get active spreadsheet, get sheets, and there are no parameters there. And then sheets.length will tell you how many sheets there are. All right. And sheets sub 1 is the first spreadsheet. Okay, I'm hesitating because I thought it was actually sheet sub 0, but not sure. Anyway, so once you have a sheet, what we did here is that says if sheets is greater than 1, then we get sheets of 1. Okay. Once we have a sheet, did we set that to a variable? Yeah, we set it to a variable called sheets, and then we now have a sheet object. It returns a sheet, an array of sheets, but sheet sub 1 returns a individual sheet object. That's where you will find your ranges. You can get ranges. You can find out, you can get the last row, which is the last row that has content. You can get the last column that has the last column that has content. You can get the data, range, which is just the entire range where there is content in in the spreadsheet or in the sheet. All right. So long as, you know, anything that's empty will not really come back. When you do things like get a range, it is returned as a range. All right. And then to get the values that are actually in that range, you would do this get values, get value or get values. Get value will return one single cell. It'll return the top left cell in the range. Get values and it will put it into an array, actually, even though the array only has one element. And get values will put it into a two-dimensional array. Get values will get all the values in the range. It will put it into an array of row and columns. And you can use that array in JavaScript, okay? For every get method or get, method, there is a set method. So if you want to set the values, you know, you can do that also. You can set values, okay? So you can get and set the contents of this here, of the spreadsheet here. Now, I'm going to go back to where I want to go. Excuse me. I'm going to go back to here just for a second, because everything that I just said, I kind of have on these notes, okay? The spreadsheet app, and then the spreadsheet, get active, gets the active spreadsheet, get sheet by name, get a range, different ways to get a range. But ultimately, that looks like a whole lot of writing, a whole lot of code, but you can perform that very succinctly. Here is one line that did all of that, okay? Values, this variable values is equal to spreadsheet app dot get the active sheet dot get the range, starting in row 2, column 3, for 6 rows and 4 columns, get the values. And that means it's going to retrieve the contents of the cells C2 to F7 in the way you're used to it as a spreadsheet, okay, from the active sheet. Now, these Google scripts, if you create them the way I'm showing you by going to a spreadsheet and going to the script editor and starting to write code there, then that script is bound to this particular spreadsheet. It only works in that spreadsheet. You can write scripts that are not bound to any particular spreadsheet. I don't think we do any of that at the gallery. There are some, and actually I would really have to go back and explore how to do that again. I did that earlier, but all the spreadsheets that we use at the gallery are associated with all the scripts that we use at the gallery are associated with a particular spreadsheet, okay? I am done with this. I'm done with this for now. And let's go back to here. So that's a very quick overview of the Google object model. Whenever I'm going to, I said this, whenever I'm going to sit down and start to develop, I open a browser window, I open up the guides, I open up the reference. And the reason I do that is because look at all this. There's no way that I know even 10% of this stuff here. So I need.
Where is that again to even put it on your bookmarks? You go to this thing, developers.google.com. That's a different website that you go to.
Okay. So, well, what I've done is, let me go back to here. At the bottom of at the bottom of the notes that I gave you, this is a link to the developers.google.com app script, which is,
Under resources.
yes, yeah.
Okay.
And yeah, I mean, you can go there, and once you go there, you can bookmark it or do anything you want, to save it. But I've given you a link to Google App Scripts, and I've said, check out the guides, and there's a link straight to the guides and the references, the reference, and that's a link straight to the reference. So this first tab I had open up here was the guides. The second one was the reference. And then I also open a JavaScript tutorial or a JavaScript reference. And so when I'm going to develop, I have something that's open to the guides, which provides me some nice code samples. I have something that's open to the reference, which is where I'm going to look to see the exact syntax. Hopefully there's a little bit of code snippet there that helps me. And then I'm also going to have a JavaScript tutorial open, which we're going to talk about in just a second about, how to write or what the elements of JavaScript are. But I mean, that's, and I've also sent you another tutorial, JavaScript tutorial, which I'm less familiar with, but it looks like it's probably pretty good. I am familiar with this one. This is where I go to remember or figure out what to do with JavaScript. Okay, so those are my resources, and I have them open in a window. Then I open another Google browser window where I actually do my development work. Okay. So Google Sheets, object model, elements of JavaScript. So any program is a series of instructions telling the computer what to do. Any program, a JavaScript program or a script, JavaScript is not just for Google Scripts. JavaScript is mostly for web development. When you look at that JavaScript tutorial, there's going to be a lot of reference to HTML code. For the most part, you can ignore that. The parts of it that you use for Google Script, the syntax is the same. It's just that whenever they're doing reads or writes or anything like that, they're going to talk about fitting it into HTML code, which you don't use at all in Google Scripts. So you can ignore that. So JavaScript programs essentially declare variables, assign values to variables. They can compare values and decide what statements to execute next based on that comparison. They can loop through a series of statements based on a condition, or while a condition is true or until a condition is met. Okay. It's a JavaScript program always consists of one or more functions, typically just one. Okay. It's a block of code, a function block of code that performs a particular task. All Google App Scripts invoke a JavaScript function. They all do. Okay. In fact, when we opened the Google script editor, it created this already for you. Function, my function, and gave you a place to start writing your code. Okay. Any computer program has data types. JavaScript programs have data types of numbers or strings or booleans, which have values of either true or false, arrays, and objects. Those are the only data types in JavaScript. It's kind of a very simplified version. Lots of other programming language have different kinds of numbers. They have integers and floating point. JavaScript doesn't. Everything in JavaScript is a floating point number. You can put a decimal point in there or not, all right? Anything that is not a number is any kind of text is pretty much a string, all right? If you create a variable and say x equals 45, then x is a number. If you say x equals quote, either a single quote or a double quote, 45 around it, then it's a text string, okay? Arrays are a collection of values that are stored in just one variable, okay? They are indexed. So you can create a variable called an array called cars, set it equal to Ford and Chevy and Honda, and cars is now an array of strings. Cars sub 0 is Ford, cars sub 1 is Chevy, cars sub 2 is Honda. Arrays, the index of arrays in JavaScript always start at 0, okay? And objects, I rarely use. I'm sure they're very powerful, but I rarely use them. But they are data types that contain one or more value, just like arrays, but instead of just being indexed, they have name value pairs. They're consistent name value pairs. So you can create an object called a person, first name Vince, first name colon Vince, last name colon Burke, age 39. That's
Right.
an object. Yeah, right.
It's like Jack Benny.
Yes, and you can add, you can objects and arrays. You can push more elements onto the array or into the object, or you can take some off. Let's see, declare numbers and variables. So I've talked about here declaring variables and assigning values. It's good programming practice to declare all your variables right up front and try to declare and initialize them actually. Although, just to help your code be more readable, believe me, I found out preparing for this that reading code that you wrote 3 years ago is not trivial. The more you can document it, the more you can, the more comments you write, the more you can declare your variables up front and stick with the kind of type, the better off you'll be in maintaining that code later. Unlike other programs though, JavaScript does not enforce strict data typing. I can declare a variable as a number and 4 lines later, I can redeclare it as a string. Or I can just assign it a string value and it becomes a string, okay? So JavaScript itself is not a very strong data type language, but you do have to declare a variable. And I'm going to show you some of this in a minute in some JavaScript programs, okay? The other thing about JavaScript, a couple of things that stand out about JavaScript in particular. The plus operator is used both for addition if you're dealing with numbers and concatenation if you're dealing with strings, okay? So if you say var x equals 3 and y equals 7 and a variable called z, and you say z equals x plus y, the result is going to be 10. X is a number 3, 7 is a number, y is a number 7, and it adds them together. But if you declare x equals 3 and y equals 7, the string 7 and z, then you say z equals x plus y. Most other languages would give you an error and say, wait a minute, what the heck are you trying to do? JavaScript just goes on its way and says, oh, that 3, since 7 is a string, that 3 must be a string also, and it will concatenate it and become 3, 7, okay? So JavaScript is on the one hand very forgiving, but it can also be easy to get unexpected results because of it. In computer programming in general, this doesn't make much sense in algebra to say x, okay, var x equals 10, x equals x plus 1. In algebra, to say x equals x plus 1, it doesn't make much sense. You think, well, wait a minute, it's equal. How can it be equal to a self plus 1? But that's exactly what happens in any computer programming, is it takes the initial value of x, 10, and then increments it by 1. So x becomes 11, okay? So I have created a demo database or demo sheet, Google Sheet, and there's nothing in the sheet, but in the script editor, I've written a little bit of code. So here is a function called declare. It declares 3 variables, x, y, and z, does not initialize them, and then writes their values and the type of function, type of variable that they are to the console. Then I set X equals 45, set Y equal to the string 45 and Z equal to the array 1, 2, or 3, and write it again to the console. And then I turn around and say X equals, notice I haven't done anything. I'm the same X, but now I'm setting it to an array. I'm setting Y to a number 0 and setting Z to some text and writing that to the console and the types. And you'll see that JavaScript just merrily went on its way and made those changes, and it really didn't care. And lastly, a better practice is I declared variable X to be equal to 0. I declared it and initialized it. Y equals a string that is currently empty, and Z equals an array that is currently empty. So if I run declare, then this is what I get. Remember at the beginning, I declared X, Y, and Z, and then wrote them to the console, and they were all undefined. That's a special value in JavaScript. They are undefined. But then I set them equal to 45 and 45 and an array, and there they are, 45 and then 45 with quotes and an array, and 45 is a number, 45 is a string, and this is an object. JavaScript treats arrays as objects. It doesn't make a distinction between an object and an array. Then I set X equal to an array and Y equal to a number and Z equal to some text, and JavaScript just went on its way and said, okay, you know, and changed all that. And then the last one is I declared those variables and initialized them, and now I know, more important that I know, but JavaScript also knows what they are. JavaScript doesn't care. It'll change it at your whim, but it's important for you to know what kind of variable you're declaring and use it properly. Now, one thing I want to show you is I wrote here and I said, without declaring this variable A, if I change that, that was a comment. The double slashes just makes that a comment. It was ignored by browser. But if I try to run this now, notice that, you know, X, Y, and Z are undefined and the types are undefined, but I do get an error because A has not been declared. So I have to declare variables. I can change them later, change them on the fly as often as I want, but I do have to declare them at least, you know, at first. Okay. Okay. I can also, JavaScript can also compare variables and decide what to do next. Those are called conditional statements. All right. An example of a conditional statement is an if or an if else, you know, structure. So here's an example. If label type equals, notice if I'm comparing, a double equal sign or even a triple equal sign is a way to compare. I'm not assigning jewelry sticker to label type. I'm comparing it, comparing label type to jewelry sticker. Else if, you know, if it's equal to the jewelry sticker, I do some code down here. Else if it's equal to small tag sticker, I do some code down here. Else I do the default code here. Okay. Back here in my demo, oops. In my demo, if I look at this function condition, here is I've set label type. I've assigned it to the string small tag sticker. But my if statement says if label type is jewelry sticker, then write this to the log. Else, if label type is small tag sticker, write this to the log. Else, if label type equals wall tag, write this to the log. Else, write unrecognized label type. Okay. If I run condition, label type is small tag sticker, because that's what I made it up here. Okay. If I change it, even just put a space out here on the end and then save it and run it again, I get unrecognized label type because it is no longer equal to small tag sticker, and it's not jewelry sticker, it's not a wall tag. So it fell all the way down through to the unrecognized label type. So that is an if, else structure, okay? It's the way you can define what to do next, change, based on a condition, do different things in a program. And finally, a loop, all right? The other thing you can do is you can repeat a block of code, multiple times, either a set number of times or until a condition becomes true or until a condition is met, okay? So an example of this is I've declared an array. This is particularly useful. A for loop is particularly useful for working through an array of values and working on each one of them. So for artists equals Helen, Martha J, Karen, Russ, Vince. Any array has a property called length, which is how many elements are in the array, okay? And a for loop looks like this: for, parenthesis, let I equal 0, semicolon, I is less than length. I set this variable length to artists.length. So it became 6, okay? And then I++ is a shortcut way of saying I equals I plus 1. It's a shortcut way of just incrementing this variable I, okay? And then inside the loop, inside the block of code, I do something with artist sub I. First of all, I do it with artist sub 0, then artist sub 1, then artist sub 2, and so forth, okay? Some things to note here: variable I is declared with the let statement instead of the VAR statement. What that means is that as soon as I exit this block of code, go down here someplace, I is undefined. Doesn't mean anything anymore, okay? So it's a way of not having, bad things happen because you forgot what a variable was set for or what you used it for, okay? Array indexes start at 0, not at 1, so I is initialized at 0, and the I++ is just a shortcut way of incrementing I, okay? Back here in my loop, I have function loop. It is a function. I define the artists. I left me out this time. I define length equals artist.length. And then I write artists and length. And here, when I write it, I'm writing the whole array. But then in a for loop, for let I equal 0, let I equal until I, so long as I is less than length, then I++. So what happens is this will always execute once, okay? It lets I equal 0, it executes one time, and then it checks, it increments I, checks to see whether or not it's still less than length, and if it is, it executes it again and increments it, and if it's still less than length, it increments it again. So each time it's going to write console.log. So if we run loop, then what happens is it wrote the entire array. That's what happened back here. Console.log artist length, it wrote the entire array and the length is 5. And then it wrote I and the artist sub I. Array sub 0 or artist sub 0 is Helen, 1 is Martha, 2 is Jay, 3 is Karen, 4 is Russ. All right. Again, let me do one more thing. Let me show you that back here, if I say out of the block, if I try to write console log I, save that change and run it again, after it does everything in the loop, and I get out of the loop and try to print the value of I is not defined. So that lets you do what's called block scope. The value, the variable is only defined within the block of code that it's declared in. Okay, in this case, just from there to there. Okay, what time is it? 7:20. All right. That is, let me go back to here. Where are we at here? So that is kind of a very, very quick overview of JavaScript. And just, obviously just like with the object model, look at all this stuff. There is a ton of stuff about JavaScript, but you kind of, you learn it as you go. Okay, I'm not sure what else to tell you. The tutorials are good. Most of it, I have a programming background. Most of this to me is kind of like, I did not learn JavaScript until later, and after I knew something about programming. Most of this, I think, you can pick up with a little bit of effort and a little bit of reading and maybe taking some of these tutorials. If you were ever interested in learning this stuff, you could always reach out to me. I'd be happy to help you as best I can. I am by no means an expert in this. Again, if I know 10% of this, I'm, probably lucky. So why do you want to use scripts in general? Well, the Google object models let you do just about anything in a script that you could do manually in the application. Okay, not everything, but most things. All right. I am basically a lazy person. If I find myself doing something over and over again, I just naturally wonder, is there a better way to do this? Is there an easier way to do this? And so oftentimes to me, it's worth the effort to put some effort at the beginning into writing a macro or a Google script, and then it becomes much easier. And when we look at count, shift, and hours, I think that's a perfect example of that in my case. All right. So anytime you find yourself doing something repeatedly, that's a good prospect for writing a script or a macro, perhaps. Okay. Executing a procedure that you do over and over again is actually less error prone than doing it over and over again manually. All right. Macros only work within a single application. Scripts can work across several applications. I can write a script in Google Sheets that will open Google Forms or open a Google document, or open a calendar, open Gmail. I can schedule meetings and send email notices. There's all kinds of things you can do with scripts. Okay. Now, there are some disadvantages to scripts. Remember, in Google Sheets, in any kind of spreadsheet, if you change the spreadsheet, the spreadsheet will take care of rewriting all your formulas for you and changing all those formulas to reflect your new column or your new row. If you write a script and the script is dependent on the structure of the spreadsheet, which is often the case, if you change the spreadsheet, if the structure changes, you are going to have to go back and rewrite your script. It's not going to take care of that by itself. All right, but let's do one more thing. We have about 5 minutes or so left, if we want to keep this to an hour. But let's take a look at count, shifts, and hours, only because this is a copy of this. Okay, it's a copy of our scheduling calendar. So when I first started doing scheduling, which, by the way, as I remember it, Jay volunteered me for early on at a meeting when Leanne said she didn't want to do scheduling anymore. And Jay kind of looked me in the eye and said, "How about you, Vince?" So thank you, Jay. But one thing that Leanne always did is at the end of the month, when a month was finished, she would always go through and manually count up the number of hours that a user worked that month and kept a running total of that, kind of reminded us, midway through the year and at the end of the year, what our total hours were. And I started to do it the same way. And that way was a matter of taking a piece of paper with the calendar printed out on it and saying, okay, here's Keith, and where else is Keith? And I would have to scan through manually looking for Keith, and I don't know where else Keith is. Oh, there's one there. So Keith had 2.5 hours on this Sunday, and he had 3.5 hours on this Friday. And so I would, you can add that up in your head. 2.5 and 3.5 is 6 hours. And then you can not find him anyplace else, perhaps, I don't know, and fill in for Keith that Keith had 6 hours. And in fact, Keith had 2 shifts in 6 hours. Well, after doing this a couple times and always, coming up short, missing somebody's name or doing something, I decided there's got to be an easier way to do this. Turns out it was not trivial, but well worth it in the end. So let me show you what happens here. I have here a calendar, okay? And I have a list of all our members down here. It's an old list, but I have a list of members down here. And what I have here for calendar name is the name as the user tends to sign themselves up in, for shifts. When Karen BG joined the gallery, Karen had to become Karen W, and Karen BG had to become Karen BG. And when Donna Doney joined the gallery, Donna had to become Donna U, and Donna Doney had to become Donna D, and so forth. David started out signing himself as David, but now he's switched to Dave, and notice that Dave didn't get picked up. So we need to be consistent. Dave has signed himself up as Dave for 2 months in a row now. So I'm going to just change his calendar name. Instead of being David, I'm going to change it to be Dave. The only thing is to do this for real, I also have to go back and do it in all the other sheets and in, the year-to-date sheets, but nonetheless.
You wiped out Donna.
Yeah, what did I do there? Okay. All right. So let me show you what count shifts and hours does. First of all, notice that I've now got a custom menu in this sheet that you don't have in most sheets. And under custom menu is this update shift and hours. So when I execute it, what it does is it starts turning all the dates, all the shifts yellow. That's the first thing it does. After it turns all those shifts yellow, except, I'll show you in a minute, it clears out all the old data and starts to turn the shifts back into white and fills in the shifts and the hours. Okay. And then that is, so far for years now, I've used this for at least 2 years, and that is pretty accurate. That is going to be an accurate count of shifts and hours. Okay. Now, it didn't turn any of these gray sheets yellow or change them back to gray. And it didn't change these blank ones at the end yellow. Okay. Those were the easy things to do. But let's look at this code real fast. So there's 2 things that happen here. First of all, I have a function called onOpen. Special function is called onOpen, which means when this spreadsheet is opened for edit, then this happens. And what it does is it gets the spreadsheet UI or user interface, and it creates a menu called custom, and it adds a menu item, a submenu called update shift and hours, and it calls this function count shift and hours. Count shifts and hours, okay? So that's where the custom menu came from, all right, in the spreadsheet. And then when I invoke it by clicking on custom and clicking on count update shifts and hours, it calls this function. So what this function does is it gets the active spreadsheet, which is the one that you're in, okay? But if the sheet name, it gets the active spreadsheet and the sheet name. But if the sheet name contains the string year to date or blank, then that's not a calendar sheet, and it puts up an alert dialog box telling you to go to a calendar sheet. So let's see. If I go here to year-to-date hours by member and say update shift and hours, I get this instead. It says, I can't update any shift and hours on this sheet. Go to a calendar sheet and update shift and hours, and it quits. Okay, it didn't do anything. All right, so I've got to be on a monthly calendar for this to work. Okay. So back here to August. So I need to be on a monthly calendar for this to work. Otherwise, it just gives me a message that says, go to a monthly calendar. The reason for blank is because I don't know how it happens, but almost every time I come into these scheduling calendars, someone has added a new sheet. I'm sure they've done it inadvertently, and I'm not sure how it happens, but I just delete the new sheets. They're always blank, but anyway, yeah. So what it does, this sheet name dot index of will return if it's looking for the string year to date, and if it finds it any place in the sheet name, it will return the position of where year to date is. If it doesn't find it at all, it will return a negative number. So if the index is returned as anything greater than or equal to 0, I know that it found it, and I know that that's not what I want to update. And so I get that UI again, I write an alert box, and then I return. I'm done with my function. Okay. Then it sets the calendar range. Now, remember what I said about if the structure of this changes, I'm going to have to be careful and come in here and change the spreadsheet. I am counting on the fact that the calendar range is always between A3 and G21. It's always 7 columns and 19 rows. It does not include these two headings. It's always from A3 to G21 down there. Now, not every month has that many, but some do. Okay, it just depends, like if the month ends on just 1 or 2 days in, it'll go all the way down to 21. So this script is dependent on that structure of the data. Okay, there's another place that's dependent on the fact that my names always begin in row 28. Okay, so if I start adding rows or doing something like that, I'm going to mess up the script. Okay, so not necessarily the best solution. Maybe I could devise some ways to really be more robust. As it is, I'm the only one that uses this. I'm the one that makes the scheduling calendars, so I choose not to worry about it. Okay, and I just go with it. Anyway, gets the calendar range. It loops through every cell in the range. So cell range is this sheet.get range A3 to G21. It returned that range as a 2-dimensional array. Okay, so I have 2 for loops for I equals 1 to 19, which is all the rows, and then for j equals 1 to 7, which is all the columns. I get the cell ij, and if it's blank, then I just continue. That's those white cells at the end that I didn't bother with. Continue just means I don't do anything else. I just get out of the loop and go. if it's not blank, if it has some content in it, then I check the background. If the background is white, I change it to yellow. Now, this notation, the way to define a color is called RGB. It's 2 hex characters for red, 2 for blue, and 2 for red, green, blue. Red, green, and blue, okay? RGB colors, all right? So FF is 256, 256, 256. That's white. 000 is black. And red and green, if you mix red and green together, you get yellow. So full red and full green and no blue is yellow. So anyway, you can, and this will define all the various colors. So if it's white, I change it to yellow. I get the members calendar name list that's always in column 3, row 28 to the last row of the sheet, meaning the last row of the sheet with data in it. Okay, so I get those members and I put that into, I get the range, I get the values, and I put that into an array called names. I clear the old data. So this sheet.getRange from 28, from row 28, column 4, for that many members, okay, and 3 columns over, I clear all that data. That's when these all got erased. This one, this one, this one, all got erased, okay? And then for each member, I find the ranges of cells in the calendar data that contain their name. And for this, I had to use something called a text finder, which is just like doing a find in a Google Sheet, okay? So I set members equals names. So remember, the names came back as a range with a 2-dimensional array. So member, an individual member, the first one is in the 2-dimensional array names K sub 0. So 00 is the first member name, okay? 1 sub 0 is the second member. So K sub 0 is Judy, K or 1 sub 0 is Robin, and so forth, okay? And I do a text finder, calrange.text finder. These I find, I remember reading code that you wrote 3 years ago is not trivial. I would have to find these over here. There's a text finder. There's methods of text finder. I don't remember what I'm doing anymore, okay? But there it is. And I would have to look for it again, or look for it the first time. But I'm finding all the places. I'm finding all the places where the member is in the sheet. Once I find him, once I find his name, there's another complication, and that is what I started to do is just like what we do on paper in order to preserve who replaced who. I started to do things like cross out a name. I probably don't have it here on any of these sheets, but on an older sheet, you may have noticed if Russ traded with Susan on a particular day, rather than just erase it, put Susan in there, in which case I lose the history, I cross out Russ. I make Russ with a strike through font and then put Susan underneath. So when I'm counting shift and hours, I'll find Russ and I'll find Susan, even though the font is strike through. So in order not to count Russ or the strike through font, I've got, there was another complication to this. I had to, after I found them, I had to break up the contents of the cell into what's called a rich text, rich text value. Rich text runs, meaning all the text that has the same font or the same attributes, and not count the crossed out font names, okay, the crossed out names. So I had to take that range. Once I found Russ's name, if I'm dealing with Russ in here, I had to take that name, new range of I, get the rich text value, separate it into runs, and go through however many runs I get and get text, make it lowercase, search member, runs equals. Okay, so if I find the member and if I find the text style is strike through, is not strike through, if strike through equals false, then I found somebody. So the member is in there in the cell and he is not crossed out. So I set the background back to white and I increment the count, which is the number of shifts, just increment that by 1. And then I see what column I'm in. Because if I'm in column 1, that's a Sunday. Column 2 is a Monday. Column 3 is a Tuesday. So I increment the hours. On Sunday, I increment it by 2.5 hours. Tuesday is 2.5 hours. Monday is no hours. And then 3.5 hours the rest of the week. So I increment the shifts and the hours. And there's one final complication that was the hardest one of all, and that's second Fridays. Remember when we had receptions? We started closing the gallery at 7 every night of the month, except for second Fridays where we stayed open till 8. So we had to add a half an hour to each shift. So a lot of this programming was knowing or figuring out much more about calendars than it was about programming. Turns out that the second Friday of any month is always going to be somewhere between the 8th and the 14th. It's just the way calendars work, okay? And so in this range where I just found somebody, if I get the column, if the column is equal to 6, then that's a Friday. And then the date of that is either 1 row or 2 rows up. Here is a second Friday. If I find, if I find Brian here, the date is either 1 row or 2 rows up. And I just have to check both of them. And if the date, I check both 1 row up and 2 rows up. And if the date is either greater than 7 or less than 15, if it's between 8 and 14, then I increment the hours both times by another half hour. And finally, I write that data, get range, this shift, this sheet, that get range. Remember, get range, this goes back to the beginning. It's K, which is, where was K? K
What
was,
happens if people divide up a shift?
well, yeah, when that happens, then I've got to do it manually. I mean, this is not going to do quite everything. It does
Okay.
pretty good. But
Yeah. And
yeah.
then the same thing for all like the out on the, the plein air West Reading hours.
Yes,
Stuff
I
from
did.
our on the avenue. You had
Yeah.
to do that manually?
Right.
Probably.
Right.
Yeah.
But once a year for plein air West Reading and once in a blue moon when people split shifts, I can handle that.
Yeah.
And what I do is I will, like, I'll typically put a note like here. There's a note in there. I subtracted 1.5 hours on 6/9 and I subtracted 2.5 hours on 6/18. 6/9, Robin worked from 3:30 to 5:40 only, so that's how I handle,
Yeah.
that's how I handle those things.
And it doesn't matter if someone has accidentally, as they often do, erased the times there and putting in their name. That
Doesn't matter. Doesn't matter. If the name is there, it'll find it.
Okay.
If the name is there and it's not crossed off, like here, this will give Leanne hours for this shift and not Donna,
Right.
because Donna's crossed off. So
And
anyway,
you still have to get the one from the gallery, right? In case there's notes on it and.
yes, yep.
Yeah.
Yeah, I still get the paper copy from the gallery, double check everything. But
Yeah.
since we've, when we were in lockdown, this is kind of why I asked, what do we want the master to be? And I think everybody at the last meeting agreed, even though I wasn't there, that this one,
They want to keep doing this. It was overwhelming. Yeah.
yes, that's good. That's good for me. So anyway,
Well, no, wait a minute. Master, they want to keep doing it in this method, but that doesn't mean that notes don't happen.
oh, no, I agree. Yeah,
Last
I will
minute.
still collect the paper and look at notes.
Okay.
But ideally, anybody who makes a note on the paper will come in here and change it here also. Maybe not. If
Maybe.
not, then
You know, like one time Crystal forgot and Marilyn stayed over a half hour and
right.
she
Right.
wrote it down. So I don't think she went in here. That
Okay.
was sometime. Yeah.
Okay.
You can go back
Um,
to July.
Okay. So at any rate, I think that's about what I have. We're well out of time. I mean, we could talk about actually making labels, which is more complicated, but there's no point in doing that tonight.
No. I
when
mean,
we
what I
got-
got out of this, I have no programming, except a tiny, tiny little bit. What I got out of it is that I could learn it. That's basically what I got out of it. Jay,
Good.
you probably got a whole lot more.
I got a fair amount because I know a little
Yeah.
programming. I'm not as advanced as Vince on this, but
I mean, no way could I really, really, really follow. I mean, I followed you, but didn't really,
Right.
learn it so I could do it. But I've got, I could struggle through and learn it if I had to.
And that's the thing. We spent an hour and 15 minutes, but a programming course is a college level course, like
Right,
a whole
right.
course, and so there's no way I can teach you anybody to program in an hour, but maybe it stimulated some curiosity. The resources are there. I pointed you in the right direction.
Yes.
If you were really interested in learning more about this, reach out to me. And that
Right.
goes for anybody watching the video too, obviously. So
Yeah. Can we go ahead and stop the recording?
I think so.
Unless, Jay, do you have any questions or anything to add?
no, I don't have a lot to add.
Okay.
Okay, I'm stopping recording.